Okay. Okay, now we are in week 9. Okay, next week, week 10. You have your presentation in week 12, right? Your project presentation week 12. Okay, so in your test 2, we'll evaluate you based on CL3, CL4. So the test 2, you will do the networking, project scheduling, and cost implication. Then another question is from chapter 7 and chapter 8, right? Approach used in product development. Okay. Okay. So what we do today is we look at what is IPPD, Integrated Product Process Design, IPPD, right? So today we learn about the standard like Six Sigma, what is Six Sigma, what is TQM, and so all these. Okay, so this is a very rough definition of effective design process. Effective design process quite similar with project success. First, you meet customer requirement. Then you talk about cost, lowest cost you have, time, and minimize the revision necessary for a design to workable. So still it remain customer requirement, cost, time, and resources. Okay, so minimize revision means you cut down the resources you need, right? Okay, so this will be the design process from idea generation to product launch. So from here to here. So this is a very important diagram when you describe how you design and how you launch the products. So this is a very important diagram for your coming assessment. So basically, the question very, very short, it asks you to explain what is the design process from idea generation to product launch. Basically, you need to draw this one and then explain. These are the 4 main process: idea generation, feasibility study, and this is a rapid prototyping process, and pilot run and test, and then you launch it. So there are 1, 2, 3, 4, 5 main phase. Okay. Okay. So this diagram alone can cost you 10 marks. Okay. So I think quite direct. You can read from the features here, right? So general idea generation, how you generate idea, you get input. You need input and output. Okay. Now, what is the input for idea generation? You have 1, 2, 3, 4, 5, 6, 7. 7 input, 1 output with this product concept. Okay, so chapter 7, the question will ask you what is the input, what is the output at a certain stage or certain design stage. Okay, so get familiar with this process flow. Right. So first process, idea generation. You input from marketing. Marketing will tell you what is the customer requirement. Design firm, this one you have a subcon or you have a consultant that give you a design, right? Consult you on based on design. You need a supplier for the component of your products. R&D department, customers, new technologies, and competitors. These are the few things that is your input for idea generation. You gather all this input. The final outcome is product concept. This is the first one. Okay. Then second phrase, feasibility studies. Your input is product concept. Output is performance specification. Yeah. Again, focus on what is the input and output of the certain process. You have 5 main process. Each process or each phrase have their own input and output. Okay, right. Then feasibility studies, the output is performance specification. Your input is product concept. Then you go to specification. Then you go to fabrication. Okay, you go to fabrication. In the textbook, they name it as rapid prototyping. Rapid prototyping. Previously, this word is used for 3D printing or CNC cutting. But as technology move on, they group everything under rapid prototyping. Okay, so under rapid prototyping, you have three main process. You will discuss about form design, you will discuss about functional and production design. So form design means the one that customer can touch, can smell, can the form the shape. Functional is the way the products function, right? Form, let's say I put a car as an example. Form is the outside shape of the car. Functional design, you talk about the car can be function on the city road, right? If you're designing a Jeep, then it should able to function in a jungle or very challenging terrain, right? This is a function, right? The steering, how steering works, and what is the ABS, and so on. This one, production design, you consider how you make it in the production, right? You want to make sure that your design, able to produce in your production line. This is more on the process. Okay, so rapid prototyping, you have specification already. Then you come to fabrication. Fabrication, you consider shape, consider form, all right? Consider functional, consider how you make it in a production or process. Okay, these three. Then these three, you have two output from the rapid prototyping phrase. You have two output. One is design specification. One is manufacturing specification. Okay, functional design form, then functional design output from functional design, you will give you design specification. Production layout, production process will give you manufacturing specification, how you manufacture it. Okay, don't confuse with performance and design specification. Performance specification is more general than design specification. As you go deeper, you'll be more and more detailed. Right, at the top is a concept. When you move down, it becomes something that you can touch, you can describe. Okay, so be careful on the output and input lah. Okay, especially this phrase. Don't confuse with the input, performance, and output design specification. These are the two that usually the mistake will be here. Okay, if your answer you write specification, don't have marks. If you only write specification, I put question mark, what specification? Okay. Then the design spec and the manufacturing spec combine, you go and have the final test. You test this one is fabrication. Fabrication, then go to test. All right. So you have a pilot test and final test. Pilot test means you prototyping, then you test it, preliminary test, you get some early results. For the pilot test and final test, your input is two, design spec and manufacturing spec. Output is final design and process plan. Okay, so your output is final design and process plan. Then once you have this final design and process plan, you can go and launch the products. Okay, before you launch, you already know the characteristic. You already know that your product is actually operating, and you're able to manufacture it. Then you launch it. Okay, so these are the 5 main phases that go through in the design process. Right, it's a design process. It's a design process kind of question. Design process phrase, that 5 phrases you describe how you do it. Okay, So how this kind of question can come out in the question or test 2 or final exam. Okay, so this one can be in question 4, question 5. You cannot run away. Like you die also, you need to answer. Right? So let's say the question asks you, the customer want to manufacture a milk products with chocolate flavor. Give a scenario. Then it asks you explain the design process from idea generation to product launch for this milk with the chocolate flavor. Illustrate or demonstrate or explain or support your answer with a flow chart, a flow diagram, a flow process. Meaning that question expect you to draw this whole process. And then you explain, you customize your answer based on the subject. Okay, for example, if the question gives you this milk product with a chocolate flavor. So you draw that one. Then in the answer, this one already 10 marks already. So one question, 35 marks. So the rest 15 marks is from your explanation for each phrases. You need to think creatively, but I still look for the keyword inside the diagram. Okay, so milk and chocolate. So what you do in your answer, you write number 1, idea generation. You write, you can write in the point form or you can write in a paragraph. As long as basically you just derive from the diagram. So you say, as the project manager, we will get input from what? Marketing, design firm, supplier, R&D, customer, new technology, discover whether there's any new technology in the milk production, any competitor that make milk products. Marketing is that they will give you the new favor or what is the current consumer favor, and it was found out that chocolate flavor will be the next trend. This one you goreng a little bit lah, right? But because the question already asked you to give an idea until you manufacture the chocolate flavor milk products. Then design firm, this one you can discuss about the packaging of the milk products, right? Suppliers for the suppliers for your milk, right? The local farmers, the cartons and all this, right? The keyword I'm looking for is supplier. Then you need to elaborate a little bit by one sentence, right? Like who, you elaborate by using the who, the 5W and 1H, 4W, 1H. Who, how, what, why, what, where. Okay, so most important is who lah, right? What lah. At the moment, you don't need to explain why yet because it's at the first phrase. You answer why at the lower part. Okay, so first thing, you get input from blah, blah, blah. I expect to see 7 input from here. Okay, so 7 input. And the output of this process, of this phrase, will be what? Product concept. Okay, number 2, you write feasibility study. Okay, you write when the what this one, right? This is the, let's say I put this one as A lah. When the A is ready, in this case, A is the feasibility, the product concept. When the product concept is ready, the team will conduct these feasibility studies. Okay, so later in the slide, I'll give you more elaboration of feasibility studies. And the output of this phrase will be what law? Performance specification, right? So in this case, performance specification, what can be the performance? Okay, okay, product concepts here. Product concept is product concept will be a milk with chocolate flavor and a few design of packaging design. Okay, then you go to feasibility studies. Feasibility studies, you group with a team, then to conduct the feasibility studies, and the output will be the performance specification, meaning you come up with like the milk label, the milk label. This is a product, a performance specification. You should mention chocolate flavor that you goreng a little bit lah. Milk with chocolate flavor that able to, you talk about time, no? Like able to last for 2 weeks, 1 week. There's no correct answer one, there's no wrong answer, as long as you elaborate a little bit on the performance specification, like what is the specification you want to do, right? So here, it give you a little bit on this one, then you have some creativity a little bit, okay? So this one is a very general, like it's a chocolate flavor that able to last for 2 weeks at the room temperature, for example. Okay. Now, if it's a car, then you will mention like what the car, how the car operate. Okay. Then number three will be the rapid prototyping. Okay. So when the performance specification is ready as input. Okay, this one also lah. Number 2 also is ready as input. The keyword is input and output lah. What is input and output? Right? Input is what, output is what. It's ready. The team will undergo 3 design studies. Okay, so here you can use a bullet presentation. You can write 1, 2, 3, or you can write in a paragraph anything that you write, as long as you mention form design, functional design, and process design, or manufacturing or production design, production process design, or production design. Okay, then you elaborate a little bit lah. Okay, so what do you do on form design? So the design team come out with 5 packaging option. For example, If it's a car, then you mention at least 2 or 3 prototyping design or form design, right? Form means shape, all right? So 5 package design or packaging design with the shape of the things, right? Packaging shape option. Then function. The R&D team come out with proposal of preserving the milk flavor and chocolate flavor throughout the process. Here you can talk about flavor, you can talk about mineral, you can talk about anything, as long as it's more on the function. Milk, why you drink milk? Here it answer why you drink this one or why you consume the things, right? So milk, protein, all these things. But if it's a car question, then you test on the car function. So it's a Jeep car question, then you mention you should able to operate in the rough terrain or rough road and all these. Okay. So if the question mention design a pen, so it should able to function as a pen for how long, right? As long as you mention the function of that object, right? You explain why you need to use that object. Okay. Then you go to production design. So this one will study the manufacturing process, equipment needed for the process. Yeah. When you elaborate, don't repeat the same thing. Don't like form here, then here also you use form. Form, you change a little bit. Form is the shape. So when you elaborate, you use shape rather than form. Okay. Function here. Function here, explain why. What is the usage or what is the how the things perform. Okay. Or why the consumer use it. Then production process, this one you elaborate based on manufacturing process and equipment you needed. Okay, or expert you needed for the milk process, especially when you pour the milk and all this. Elaborate it. So if it's a pen, then you have to think like how you assembly the thing. Right? Assembly. These are a few words that help you to elaborate. Okay, so this is how you answer question 4 or question 5 or coming test 2, question 2 kind of question. Right? So diagram, if you're able to draw correctly, 10 marks already. Then the rest is elaboration on the diagram, 15 marks. Right? Either go, no go test. You understand or don't understand. Okay, so number 3, once you do the rapid prototyping, then you go to number 4. Okay, so here, after you explain already, remember, if you stop here, then you'll miss some marks. Again, we focus on input and output. Write something about the output. The output of rapid prototyping will be, or the output of functional design will be what? This one will be C. Output of product design will be D. Okay, will be design specification and manufacturing specification. So this one you mentioned. So it complete number 3 rapid prototyping process, right? Then number 4. Number 4 is pilot run and final test. Okay, this is more on experiment, like how you test the design specification and manufacturing delivery. You elaborate based on, you say, the input of this process or input from this process is from the input of this process from the input of this process is from functional design is from this design input the input of this process. You don't need to mention this one is what is C. Okay. C is design specification. So how you test your design? You run analysis. You run lab analysis. You run market analysis. Okay. You can elaborate based on this 7 point here. Okay. So you do the keyword here is you do testing, you do evaluation. Okay. So the one you can do, you do control lab analysis, you do market analysis. So here, lab analysis, if it's a milk products, so how do you run lab process? The milk with chocolate flavor is tested in lab at different temperature and pressure. This one you elaborate based on different country, weather, and supply. So this one you elaborate temperature, pressure, and so on. This one, market analysis, you run a survey at market. This one on people, right? So you run a market from a different country or consumer from a different country, because different country have different preference, right? Same, if the question change to pen, change to automotive products or electronic products, it's still the same, but you mention the products again. Like you run the market survey for the milk with distributing the products as a sample to different from customers from different country and get input or get their feedback. Okay. Here you can talk about safety, how you test the safety, right? Durability, all you learn in your engineering material, right? Durability, how it can loss run, how if it's a milk, then it's become food safety. Then you can talk about the packaging, right? Can the packaging last for a drop and all this, right? So all this important is the output. The output here is the final design and process plan. So here, after you run, the output is final design. Then you say, another input of this process is what, D, D is manufacturing deliverable specification. The production team and engineer will you don't say use the word will studies and tests, because this phrase is rapid prototyping, you're fabricating the thing, right? Studies and tests the production process to make sure it is possible to make or something lah. Okay, so this is the input and output. So this is input, and the output is what? No? Is the final process plan. Production one is process plan. Okay. So here you have E, you have F. Not F lah, same lah. E and F, E1 and E2. Okay. So output is final design and process plan. Then number 5 is the new product launch. New product launch. Of E1, E2. Now the product is ready to launch to the consumer. Okay. And the process end here. Okay. So there's no output already. Output is no. That means you already run the product, so the process will end here, right? Or you can say that if need improvement, you look back to step number 1. Okay. Okay. So here you can say like you collect input, collect feedback from sales team about the new products and so on, right? And use it as an input for the new product development. Okay, so this is how you elaborate. 10 marks for this diagram, 15 marks for elaboration of these 5 phrases. So each phrases have 3 marks. Okay, so this is the expectation of the answer. Okay, so it's like essay question. Rapid prototyping. Where? 1, 2, 3 marks. So these two form will give you form. You need to start with the shape first, like you design a car shape. Then shape will split into 2, functional and production. Like once you get the form already, you split your team into 2. One give you the functional, like steering, what is the shape of the steering, and so on. Then production is like how to fabricate the steering. I want to subcon it, you want to do it in-house, and so on. For example, lah. Okay, you start with the form shape first. Then output here is from form design to function. It come out with a design specification. Form give you production. You come to manufacturing. Of course, these two are correlated, but these two are the main process from the not main lah, but it's a output from these two. Okay, then you give you the manufacturing spec and design spec. Yeah. Yeah. Okay. So the rest you read lah, from the PowerPoint slides, already elaborate on the whiteboard. Okay. So this lah, already explained. This one you read lah. Okay. So in the concept generation, you come up with perception maps. We don't go into detail, but of course in the test you don't need to mention this one in detail, but this one is just to help you like how you elaborate the 3 marks for the first process. Okay, so for example, for idea generation, usually the company will come up with the perception maps. It compare consumer perception of the company products with the competitor products. Okay, so in this case, I give you a serial example. Serial example, for example, if you're making cereals products, so the map will give you nutrition and taste map. So this is a neutral ground. You are actually looking at taste and nutrition. Our example on the whiteboard here is chocolate flavor. And one more is another one for you to think about it, right? So normally there will be two parameter and packaging, chocolate and packaging, right? So here for cereal is taste and nutrition. So the one is towards high and low, or good taste, bad taste. So they do perceptual maps for the competitor in the market. So all the name that you see on the slide here is their competitors. All right. So like for example, Cheros. Cheros, they are high nutrition, but toward bad taste. So Ray's Crisp Grill, they are bad taste and low nutrition. But there's one, Cocoa Puff. They are good taste, but low nutrition. So there's no one inside here. The market empty here. No one inside here. Okay. So they do a studies. Then they try to sell a new product cereals that try to sell in high nutrition and good taste. How you add good taste is very subjective. For example, this example, they add honey. Honey tastes sweet, good. So they add the team in the idea generation, the team contribute like okay, they add apple cinnamon, they add honeys for the new products. Right. For the one that we discussed just now is chocolate flavor and packaging. Right. Yeah. So for example, all this lah. Okay. This one you read lah. So then they do benchmarking. What is benchmarking? Benchmarking, you are comparing with the best in the industry. You do benchmarking. So example for your degree program, university also do benchmarking. Okay. So and also recently we are in the world ranking, top 600. That also part of the benchmarking process. Right. All right. So for example, the black card, master red card. So what is the black card? What is they famous for? Maybe your father had this one. Okay, or maybe you have lah. When you have this card, like for example, if they do benchmarking, you want to launch a banking products, you benchmark this card. This card is unlimited spending, and you don't need to worry about the transaction. Sure can go one, so can pass one, right? Fast transaction, unlimited amount, and so on. Right? So these are big process. Disney, what is their selling point? If you benchmark, you want to open up an entertainment theme park. Disney, what they known for is happy. They sell happiness, right? So no matter how is your day, you walk in there, you see everyone, all the staff will smile to you, right? Yeah, you see Mickey Mouse and all the cartoons, they have a smiling face. Although it's a mascot lah, but it sell happiness, right? And also quality. So quality. Although some station you need to wait a long time, But along the waiting time, they strategically, they put something along the way. Like you wait for 30 minutes, along the way, they will try to sell you something. Okay. FedEx, they are known for their speed of delivery. Although they are expensive, but they are very good in delivery time. Okay. And any places they can go. Right? Although expensive, but what the customer want is fast delivery. Like nowadays, Shopee, you want to buy things, you want to arrive tomorrow, right? So the ecologies change every year. Every year, new technology come in and so on. Then idea generation also can do reverse engineering. One of the input is from your competitor. How you do? You buy a competitor item, you come back, put into the garage, dismantle, and look for what is the technology. This is what happening in the industry, and that's why China they can become such a good country nowadays. 10 years ago and 10 years from now, present day of China is different because their reverse engineering is very, very good. Until all the chip company don't dare to go in anymore. Okay, any product go inside China, China able to manufacturing it. Okay, so this is reverse engineering. Okay, you want to study the technologies, you use reverse engineering procedure. All right. Okay. So many products following consumer computer leads to not enough. So consumer, this one you read lah. So you need R&D for new ideas, right? If you are already the leading brand, like Mercedes, BM, Tesla, right? All this, you're already in the leading. So what you do as a leading company, you need to develop new products. So your R&D department is very, very good. For example, Dyson, they are the leading engineering company that's selling consumer products. So their R&D department is quite strong, right? Okay. So feasibility studies consists of market analysis, economic analysis, and technical strategy analysis. Okay, this one you read lah. So what is market analysis and so on. Okay. You compare the price range and so on. You estimate risk. Then technical strategy analysis, you answer all these questions, and all these questions will help you to elaborate point number 2. Okay, of course, you don't write all these questions. You answer this question, put your answer here. Okay. So all this lah. You only need to memorize 3 questions from here, then you put inside the number 2 question for number 2 process. Okay. Performance specification. Okay. Then rapid prototyping is the third phrases. So they change the ideas into physical products. So they come up with design spec and manufacturing spec. Okay. They have performance specification, and then come up with design and manufacturing. Okay. So rapid prototyping, rapid means very fast, right? Okay. So important that this design process can perform concurrently, means parallel process. So some factory they use concurrent or concurrent design process. Okay. So effective design is that this one is very traditional, means you need to jump the wall to pass on the information from customers to production personnel. But for concurrent, you actually sit down everyone sit down in the same table, you discuss what is the customer need, what is the marketing needs, and so on. Okay. So definition for concurrent, you read on the screen here. Okay. Okay, form design. Form, it shape, color, size, style, aesthetic, right? So in many cases, functional design must be adjusted to make product looks good and feel right at this era. Okay, the good example is your iPhone. Okay, they are the one who leading the engineering products to looks good. They're actually changing the ecosystem when they launched the iPhone with color screen and all this. They are the one who first introduced a color screen phone with a touch screen, right? Of course, Nokia also chasing up. After that, then they lose the competition. Okay. Like for example, the form design for this Mazda sport car and so on, right? So they have a specification, a function design there. So functional design, for example, this robot, right, is able to make you laugh and all this, interact with you. And they actually design for a specific market, right? Okay. So this one you read lah. This is another example of functional design for Dyson. You look at the shape, you already know this is Dyson. Right? It's a fanless devices. Right? Okay, what is reliability? Is the definition here, right? So car warranty, so and so, right? So of course, milk product don't have warranty lah. But what can you elaborate based on food products? Is the expiry date of the food. Like for example, you can last for 1 week, 2 weeks, and so on. Okay. Okay. And all this you read. Okay, there's one calculation in this chapter, which is reliability. Okay, reliability. So what is reliability? This one under design form. Okay. This reliability equation will be like your electric circuit teach by Jurida. Okay. So the total system reliability, if it's parallel, then you're having reliability 1 multiply number 2, number 3, number 4. For example, if 2 components required and each have reliability of 0.9% or 90% reliability, okay? So the component you put in series, 0.9, 0.9, the total reliability will be 81%. Okay? This one come out in test 2. Okay? So if you have 3, then you just multiply 1 more. What does it mean? It means if one object fail, it will affect the whole system. Okay. Okay. So this one is a series component. You take the reliability, multiply until the last item. Okay. So even though the individual reliability is 90%, but if your assembly as a series, your system, your equipment reliability will be 81%. It's not as good as individual components. Okay. So if your customer's expectation is 90%, you will get complaint most of the time. Why? Even though you say that your individual component reliability is 90%, but you tell your customers reliability of your equipment is 90%, you will get complaint. Why? Because the customers are receiving the assembly component. The product that you sell, you combine with a lot of components. In this case, 2 components. the total reliability for the products that customer receive is 81%. Okay. So you need to be careful when you have this kind of system, right? Okay. So how can you improve this system? You have backup system. Backup system. So this one is a failure component, like brakes, all these are. So these are the car reliabilities. All are connected. This one, if one of these broken, your car reliability drop to lower value. Okay. This is brakes, for example. All right. And so on. So you know the brakes is important. And if your brake broke down, you don't have backup, it's a very weak scenario, right? So what we do, we have a backup system. Let's say your original is 95%, 95%. Then you put a backup on top of the original component. The equation changed already. It become, you need to use this equation. Our system equal to 1 minus bracket, 1 minus R1 bracket, 1 minus R2 bracket, and so on. Okay. Why this equation change this one? This is parallel. If you study parallel diagram or circuit, how do you get your resistance equation? 1 over Rs equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. You flip the equation, you get this one. Okay. So if you take this as example, meaning original fail, this one will take the role of original parts. So if you substitute the value, R1 is the original one. Original one multiplied by the backup. Your value you get what? 0.995. 99% won't fail. Okay. That's why in aircraft, in nowadays smart cars, you have backup systems. For example, brakes, you have ABS system. Even though your ABS, not ABS, but even in aircraft, even though something fail, you have a backup system. Okay. So there are two ways. This one. So go for this example. Then we have a short break. Right. Okay. Determine the reliability of the system of the component. It's like a circuit. It's like a circuit. So determine the reliability of system. There are two equations to use just now. There are parallel system and there's a series system. Will be like your circuit diagram. There are two equations. When there's parallel, Rs equal to 1 minus R1, 1 minus R2, and so on. Rs, this is parallel. This is series. R1, R2, and so on. Okay. So again, always good to write equation when you solve problems. Okay. Same for your test 2. Remember to write the general equation first, especially when you calculate the future value, present value. Okay, write the equation first. Okay. When you solve this kind of question, how you do? How you do? It's like when you do addition, multiplication, minus, division problems, right? You have a priority to do, right? Right. For example, 3 plus 5 divided by 2, right? Divided by 2, minus 5. how do you process this information? You do divide first, right? Okay. Same with this one. How you do? You calculate this one first. Huh? Calculate this one first. So what is the reliability of 0.9 and 0.92? What is the R system? I already give you the formula here. Substitute the value. What is the reliability? What do you get? 0.992. Okay, decimal place minimum 2, but for this kind of question, you need 3. Okay, for this question, this kind of question, you see the question asks you about reliability, minimum 3 decimal place. If you go for 2 decimal place, you get 1. There's no 1 in this world. There's no 100% reliability. Okay. Okay, so once you get the center one, you transform. This is the first step when you look at this kind of question. The first step, you draw the diagram, 0.5, 0.90, 0.92. You calculate, you write this equation, substitute, you give me the answer, this one. Okay. Then second one, you pull in the value, 0.98, 0.992, 0.98. This becomes series. Write this series equation. Take this one, multiply this one, multiply this one. So what do you get? 953. Okay. So it means it works 95%. Okay. Okay. So this one go very fast. Okay. So the answer is 0.51. So not sure. You need to check. Maybe I'm wrong, or maybe you're right. Yeah, this one is 2 decimal place. All right. Okay, but the idea is there, right? You take the parallel system first, then you do. Okay. We go for example number 2, then we call it a day. I see you in the afternoon. Okay. This is more likely your test 2 or final exam question. It's quite long, but actually it's very easy to solve question. You draw a diagram. You see the question, you already know. You see the word reliability. Write these 2 equations in your answer. You get 1 mark here, 1 mark here. Before you solve. 25 marks, you get 2 marks for equation. Very easy already. Okay. So Jack is a production supervisor for a company committed to improve the new quality. Part of the program, they try to make in-house and ensure higher quality level. Systems seem to be working well. One assembly required. One assembly. What I mean by one assembly? This means one assembly. This one also can mean one assembly. Means one system. It means one system. One assembly required 95% is normally purchased from a local supplier. Now it being assembled in-house from 3 components. So it means your system have 3 boxes. You don't know how to assemble it. Right? You have 3 boxes. It can be either this way or this way. Right? So it purchased assembly in-house with 3 components that each boosts reliability of 0.96. What is the individual component reliability? 0.95 or 0.96. Okay, it tell you already 3 components that each reliability is 0.96. And this assembly. Okay. So you draw R1, R2, R3. Okay. So you say one assembly requires reliability of 0.95, meaning your RS 0.95. Okay. A, customer complaint has risen in 3 months since the company start doing its own assembly. This is own assembly. Can you explain why? What is the system reliability of the own this one? This is series or parallel? Series. So what is the equation? You press calculator, what is the reliability? 0. 885. Can you explain? A, why? 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 Why customer complaint risen 3 months when they start to do their own assembly? Why? Huh? What is the required value? Your explanation should mention customer expect reliability of 95%, but from the calculation, the assembly parts give you the total reliability of 0.885, lower than 95%. What does it mean? If customer buy 100 parts, he expect 95 parts works well. But when you deliver to customers with this assembly, you deliver hundreds, only 88 parts works. So like if you manufacturing car, you promise you 100 cars, 95 cars, no problems. But when you deliver 88 cars, no problems. So you have like 12 cars always sent back to the workshop. Or customer complain why my car cannot start and all this. Okay, so this is how you explain. You do calculation, you write general equation, you draw the diagram, you calculate, you get one answer compared to the what customer expect. In this question, 95%. So your answer is one. B, what level of component reliability is necessary to restore the products to its former level qualities? You understand B question, right? So how you develop the equation? Now you know that first case is 88.5%. B, he asks you, what level of the component reliability is necessary to restore former quality? Your object now is 0.95. Okay, you draw the diagram again. You want to reach RS 0.95, R1, R2, R3. Your RS equal to R1, R2, R3. Your R1 equal R2 equal R3. So RS equal to R1 cube, 0.95 R1 square cube. What is the answer? What is the answer? You understand the question, right? I'll try to understand the question. Who don't understand why we cube root the things? Who don't understand? Okay, now. So what is the answer? 0.983. So for question 2, each component reliability should be 0.983 or 98.3% reliabilities to meet total system 95%. Okay. Number 3, Jack can't increase the reliability of individual components. He cannot. He cannot increase the individual components. However, he can add the backups with a reliability of 90% to each component. If the backup have a reliability of 90%, how many will be needed to achieve 98% reliability of the assembly? This question asks you to design a backup system. How many backup systems you need? What is the original system? R1, R1, R2, R3, 0.96, 0.96, 0.96. It cannot increase anymore, 96%. Now, he say he can add a backup. Your backup, reliability is 0.90. How many backup you need to achieve what? RS 0.95. This is your objective. This is your target. What mean by how many set of backups? This mean one backup. This mean two backup. This mean three backup. Okay, you have one set, two set, three set. The question asks you how many backup system you need. You need to test the system. The answer, 1, you do first testing. You draw lah. You add one backup, R1. So you calculate one backup system. What is the RS? What is the RS? What is the RS for backup, one backup system? What is R1 reliability? (0.96). What is the backup reliability? So what equation you use? RS equal 1 minus bracket 1 minus R1 bracket 1 minus R2 close bracket. This is your backup, right? So R1 0.1 minus 0.16, 0.04, 0.1, multiply this one 0.00. 1 minus 0.04, 0.996 for one system. You test lah. This one give you 0.996. This one 0.9. What? 0.96, 0.96. You calculate by series equation. This one multiply, this one multiply. RS for one backup. How many? 0.92. Okay, let's say you get 0.92 lah. What is the objective? 95. Not enough. In your answer, you should write one backup, not the option. Or you continue, number 2. What's number 2? You add one more backup. Add one more backup here. You draw, number 2, you draw another set, this one. Then this one become 0.996. You do the same. For second set, RS will become 0.9 something, 96 or something. Okay. Of course, in test or exam, we will make you suffer. We will give you very low number. We want you to do until 3 or maybe 4. Yeah. Or if the question asks, your backup can be, this is one backup. You can ask, hey sir, can I put my backup on top here or not? The answer is yes, but normally you don't need to have one backup after backup, unless you are in the aviation industry. Aviation industry, you have more than 2 backups. Okay, if you have more and more backups, you are near to 0.9999, 99.999%. If you take 96%, you add backups by using this formula, you're very, very near to 1. But it's not 1, 0.996. It's a fail-safe devices. Okay, but when you in the industry, normally we just add one more backup, like you put in the fuse as a backup, right? So that is how you do it. Yeah, this one. Yeah. It depends on operation, like aircraft. Aircraft, you cannot sacrifice one system down, then it will link to other. In aircraft, you have more backups. But in normal consumer, some not even have backups. Some like have this one, you just add this one. Okay, and you add one backup means you add cost already. Manufacturing cost. Okay, so I'll just show you the answer. You already have the answer. So the system will give you 0.885 reliability. So the complaint is valid. That's why you get a complaint, because you are less than expectation. Number 2, you cube the things, you get individual 9.983 individuals to get 95% reliability. Number 3, you need to do calculation for backup plans. Of course, you try to put this on here lah. The front first, then second. Of course, this one correct also, right? Correct. So this is one backup system. So one backup, you calculate the calculation, you get 0.996. Okay. Although you see the calculation a bit different from the formula, but it's still the same. You still get the same answer. You test second backup, you get 95%. Third backup, 0.88%. So since 2 backup already reached expectation, you stop here. Okay. In the test, if you already get the answer, you don't need to go for 3 backups. Okay. Okay, this is how you do lah. All right. Okay. We continue this one this afternoon. Okay. We stop here. All right. It is